Hello, this is Math Step by Step, and today we're going to solve system of equations using the substitution method. So let's go to our first problem. Here we have two equations. I'm going to call the first equation equation A and the second equation equation B. To solve system of equations, you have two main methods. One is the substitution method, the one we're going to see now, and the other one is the elimination method. But I will suggest that whenever in one of your equations, like for example, look at equation A, you have one of your variables already isolated, meaning already by itself on one side of the equation, I would suggest that you use the substitution method because it's the easiest thing to do when one of the variables is isolated. So we're going to go ahead and do that. Okay, since in equation A, y is already isolated, what we're going to do is that we're going to plug in what y is equal to. Y is equal to x minus 8. We're going to plug in this x minus 8 in our second equation where the y is here. Instead of writing y, we're going to write x minus 8 on the second equation. So I'm going to go ahead and do that. So my second equation B is 3x plus y, but as I said, y is x minus 8. So I'm going to write that plus x minus 8, and that is equal to 4. So now I have one equation with only one variable, which I can solve for that variable, for x in this case. But before I start doing anything, I see that I have two like terms here, so I'm going to combine them. 3x plus x plus 1x, that's 4x. So 4x minus 8 equals 4. So now, in order to find the value for x, all I need to do is get rid of 4 and to get rid of negative 8 to have x by itself on the left side of the equation. So which one do I do first? Do I get rid of do I get rid of 4 or negative 8? As always, we will start with the number that is farthest away from our variable, which in this case is negative 8. Since it's a negative 8, to get rid of it, I'm going to do the opposite operation. I'm going to add 8 on both sides of the equation. So on the left side, I can see that minus 8 plus 8, that cancels, and all I have left on the left side is 4x. On the right side of the equation, I have 4 plus 8, which is 12. So now, to isolate the x, all I need to get is rid of 4. The 4 is multiplying the x, so to get rid of it, I will divide the opposite operation of multiplication, division. I'm going to divide both sides by exactly the number I'm trying to get rid of, which is 4 in our case. So with that, you can see that we can cancel the 4, and I have x by itself as we want it on the left side, and 12 divided by 4 is 3. So x is equal to 3. Am I done? Not yet, because as I've said before, when you're solving a system of equations, you're finding a point where the two lines intercept. A point is x and y written like this. I just found x, so I know that x is 3, but I still have to find y to have my point. Look at equation A and have in mind that you have x and you're trying to find y. See how y is already isolated on equation 1? On equation A, I'm sorry. The easiest thing to do will be then use that equation. So we will use equation A where y is equal to x minus 8. Since we already know what x is equal to 3, we're going to plug in the 3 there. So y is equal to 3 minus 8. And 3 minus 8 is negative 5. So my point, if you want to write your solution as a point, will be 3 and -5, as you can see here on top. Let's see our second example. I'm going to write the first equation as equation A and the second equation as equation B. Do you see any of the variables isolated on any of the two equations? Yes, x is isolated, meaning by itself on one side of the equation, on the second equation, right? So what I'm going to do is to plug in what x is equal to. X is equal to 2 minus y. I'm going to plug that in where the x is in the first equation. So I'm going to write here my first equation. Equation A is 4x, but x is equal to 2 minus y. Now, here we have a thing. This 4 needs to multiply all of this 2 minus y, not just the 2, not just the first number 2. All of this expression 2 minus y. So how do I say all of it in algebra? Using parentheses. So the 4 is going to multiply this whole 2 minus y term. And then I continue writing my equation A. Minus 2y equals 20. Now, I have an equation with only one variable, which is y. But the first thing I need to do here is to solve these parentheses. Since these two things are not like terms, I cannot add them. The only way to solve this parentheses is by using distributive property. So I'm going to multiply the 4 times the 2 and the 4 times the negative y. Let's go ahead and do that. 4 times 2 is 8. What sign will come after the 8? It will depend on what I get when I multiply the 4 times the negative y. 4 times negative y would be minus 4y. And then I continue rewriting whatever else I have. Minus 2y equals 20. Now, as you can see on my next line, I have two like terms here that I need to combine. So everything else, I'm just going to rewrite it. Now I'm going to add these two like terms. So I need to add a negative 4 and a negative 2. Same sign, so I need to add and keep the sign. 4 and 2 is 6, and I keep the sign, so 6y equals 20. Now I need to isolate the y, meaning I need to leave the y by itself, so I need to get rid of the negative 6 and the 8. Which one do I start with? As always, I start by the one that is farthest away from my variable. So I need to start with the 8. Since it's a positive 8, the opposite operation will be subtract 8 from both sides of the equation. On the left side, the 8's cancel. 8 minus 8 is 0. And I have a negative 6y equals, don't forget the sign. This is not just 6y. It's a negative 6y. Don't forget that part. And on the right side, 20 minus 8, that will be 12. So now, to isolate the y, I need to get rid of the negative 6. The negative 6 is multiplying the y, so to get rid of it, the opposite operation would be division. Divide both sides by exactly the number I'm trying to get rid of. I'm trying to get rid of negative 6, not 6, negative 6. So I divide both sides by negative 6. So now I can cancel that negative 6. I'm going to continue here. And y is equal to 12 divided by 6, which is 2. And a positive divided by a negative is a negative. So y is equal to negative 2. Am I done? Not yet. Remember, as always, a point is x and y. And I already have y, which is negative 2. But I don't have x yet. So I need to find x. If you look at your two equations, you can use any of the two equations to find x. But it will be way easier if you use the second one because you have already x isolated or by itself. And since you know the value for y, you plug it in here and you're ready to find your x. So let's use equation B, which is x is equal to 2 minus y. So x is equal to 2 minus, but y is negative 2. So minus negative 2. Do you remember what happens when you have two negatives in a row? A negative and a negative is a positive. So this will be x is equal to 2 plus 2. And 2 plus 2 is 4. So there's your point. X is equal to 4 and y is equal to negative 2 here on top. Okay, let's see the next, and you're done with that. Let's see the next system of equations. Again, I'm going to call equation A and equation B. Let's see if one of the variables is already isolated. Take a close look at both equations. Yes, in equation A, y is already by itself on the left side. So all I need to do is plug in the y with what the y is equal to, which is 3x plus 4, where the y is on the second equation. Okay, remember, whenever you have a variable already isolated, like in this case, the easiest thing to do is to use substitution method. Otherwise, you probably want to use elimination method. Okay, so let's rewrite equation B, and we're going to plug in 3x plus 4 where the y is. So 3x minus y, but y is equal to 3x plus 4. So I'm going to write that. But I have a negative here. That will change everything I have here in the 3x plus 4. So I need to write a parenthesis here to write the 3x plus 4. And then I continue, equals 8. This is like having here where I have the negative in front of the parenthesis, is like having a negative 1 here, right? So if I use distributive property and I multiply negative 1 times 3x and negative 1 times 4, I will get rid of the parentheses using that. Everything else, I'm just going to rewrite it. So the 3x, the equal sign, and the 8, I just rewrite it. And now I will start with the distributive property. Negative 1 times 3x, that will be negative 3x. Then negative 1 times 4, that would be negative 4. Okay, I do see like terms here. 3x and negative 3x. And 3x minus 3x is 0. That cancels. So all I have left is negative 4 equals 8. So what happened here? I wasn't able to find my x or my y, right? What happened here? Let me show you on the next screen. Whenever you solve system of equations, you have either using any of the method, the elimination method or the substitution method, you have three possible solutions. The first solution is this one, where you're able to find a point and the point will be that one where the two lines intersect, and you have one solution and you're able to find x and the value for x and the value for y. But it can also happen that the two lines are parallel lines. When that happens, you have no solution. Why? Because the two lines never intercept each other. They never touch. So you're not able to find this point where the two lines intersect. When that happens, you have parallel lines and you have no solution. And how will you know if you're using algebra? You're actually not seeing the graph for the lines. So how will you know? Because you will get to a statement like this. For example, this is just example. 5 equals negative 6, which is not true, right? Well, when you get to something like this, is because your system of equations has no solution because your lines are parallel lines. So whenever you get to a false statement, you have no solution. Now, it can also happen that you have coincident lines, that this is line 1 here, your first equation, and then your second equation, I'm going to write it in green, is right on top of your first equation. That one is line 2. They are coincident lines. And what happens there is that when you have coincident lines, you have infinite solutions. And that is because the line intercept each other on every single point. They overlap. The points belong to both lines, every single point. So you have infinite solutions. And how will you know that if you're using algebra? You're not seeing again the lines. Well, because using the algebra, you will get to a statement like, I don't know, let's say 3 equals 3, which is true, but you were not able to find a value for x and a value for y. So let's go back to our example. Doing the algebra, and no matter what you did here using elimination or the substitution method, your variables here are gone, and you have -4 equals 8. You were not able to find x and y. And this, by the way, is false, right? So whenever you get to a false statement, you have no solution for your system of equations, and your lines are parallel lines. Okay? Okay, so that will be all for today. And if you like this video, I hope you subscribe, and see you in the next video. Bye.